Hello everyone, I am Shivam Pasari and welcome to Asian Academy. So as you can see from the title of this video, in this video we'll solve another question on the topic of number system, and the question is as follows. Let S be the set of all natural numbers less than 120 such that the HCF of any element in S and 120 is 1. Find the number of elements in S. Now we are provided 4 options for this question. Option A 104, option B 56, option C 64 and option D 32. So this was our question, and I would like you to try this question first by yourself and then come to this video for the solution. I hope that you've tried the question and you've got the solution, and if you didn't, then let's check the solution. So according to our given question, we are given a set S which starts from the number 1 and goes up to the number 119, because S is the set of all natural numbers less than 120, so it starts from 1 and goes up to 119. Now we have to find the number in set S such that the HCF of 120 and any number from the set S is equal to 1. Now HCF is basically the highest common factor or the greatest common divisor. So let's take the example of 4 and 2. The HCF of 4 and 2 is equal to 2 because the highest common factor between 4 and 2 is equal to 2. Same for the case of 6 and 8. The highest common factor between 6 and 8 is equal to 2, and for the case of 5 and 10, the highest common factor between 5 and 10 is equal to 5. So the largest factor that divides both the numbers or any set of numbers is known as the highest common factor. Now this was the basic introduction for highest common factor, and let's proceed with the solution. So according to our definition of HCF, the number 120 and any number from the set S should be having a highest common factor of maximum 1. So let's take 120 and 1. The highest common factor is definitely 1 because we have 1 itself, so there is no other factor in 1. Now if we take 120 and 2, this is not true. The HCF of 120 and 2 is equal to 2. Now we have to go up to the number 119, and to check all the numbers by this method is very lengthy and tedious. Now to solve it quickly, we have a formula that is known as Euler's Totient function, which is represented as phi n, which says that the number of co-prime numbers less than the number n is represented as n into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c. Now it says that the number of co-primes less than n. Now co-prime of a number is basically the exact definition of what the question is asking. If two numbers have HCF as 1, then they are called as co-prime to each other. So by finding the value using this formula, we'll basically solve the question. So we just have to find the number A, B and C, which is basically the prime factors of 120. Now a number can have more than 3 prime factors, but 120 has only 3 prime factors, that are 2, 3 and 5. So if there are 4 prime factors, then we'll have 1 minus 1 by D, 5, then 1 minus 1 by E as well. So according to this formula, our answer is equal to 120 into 1 minus 1 by 2 into 1 minus 1 by 3 into 1 minus 1 by 5. Now if we simplify it, we'll get 120 into 1 by 2 into 2 by 3 into 4 by 5. Now 2 and 2 will get cancelled. 3 into 5 is equal to 15, and 120 by 15 is equal to 8, and 8 into 4 is simply equal to 32. So the number of numbers which are co-prime to 120 and which are less to it, basically having a HCF of 1 with 120, are equal to 32, and according to our given option, it is option number D. So our final answer is option number D, 32. That was all for this video, and I hope that you understood all the topics covered in this video. And if you have any doubt, then you can post your doubts down in the comment section, or you can send your doubts to us to our channel's official Instagram or Facebook page, and we will surely solve your doubt as soon as possible. Or you can go to the official website of Asian Academy and you can send your doubts to us from there, and all the links are provided down in the description. And if you did like the video, then please hit the like button and subscribe to the channel Asian Academy.